Hey, and welcome to this lesson video from our in-class notes that we took. So if you weren't here or you just need to rewatch, this is the lesson where we used our property of exponents with expressions that have rational exponents, and that's exactly what our learning target says. We can simplify expressions that have rational exponents. So all of the properties that we know from before are going to apply. But before we started into the actual learning target, we recalled what was the previous night's lesson video. And what this says is the cube root of 27, we want to square that. Well, it makes sense first figure out what the cube root of 27 is. Now, in class we talked about how you could use your calculator, or you could still do the traditional factor tree. This index tells me how many I need in a set. And by golly, I got a set of 3s. So what that means is instead of cube root of 27, I'm really talking about just a 3, because the cube root of 27 is 3. Okay, so the cube root house goes away because everything matched up in my set, so it simply is a 3. And I still have that power on the outside, so I'm 3 squared, I'm going to get 9. Okay? Now, here is the rational exponent, this fraction as an exponent, but notice in this example, it's a negative. So right off the bat, you want to flip 32 to the bottom of a fraction, because that's what we do with negative exponents. We flip them, okay? Now, this rational exponent 4/5, remember the key word in a previous lesson was power over root. Okay, so the root here is a 5, so I'm going to take the 5th root of 32. Think about how it was set up in the previous example we just did. I'm going to raise it to the 4th power. Now, if you want to do a factor tree, let's see, 2 and 16, 2 and 8, 2 and 4. Looks like I'm going to end up with 5 2s, which I need 5 of something to have a set. So I had just enough to create a set of 2s. So when you have a set, that means one of those numbers come out. So it would be a 2. There's nothing left over, so this 5th root house goes away. So I'm simply looking at doing 2 to the 4th on the bottom, which would give me 1/16. Now, our property of exponents that we've learned before, currently the previous week of where we're at right now, all of those properties, no negative exponents, no zeros, no repeated variables, all of those things still apply, even though you have exponents that are fractions. We would still do the same process. So let me go back to the slide and just recap. Remember, when we had, let's say, 2 x's, that we multiplied, remember we added those exponents to get x to the 5th. When we had an x cubed that we squared, remember we distributed that power in and we multiplied those exponents to get x to the 6th. When we had x on top and an x on the bottom, when we worked with integers, we wrote them out. So we wrote out 5 x's, and we wrote out 2 x's, and we canceled them. But notice what's happening. 5 and 2, if you subtract 5 minus 2, you end up with a 3. 5 and 2, 5 is the bigger number, so you have 3 left on top. Okay, and if we had other stuff in our problem besides just x's, we would always make sure that the x ended up on top of our fraction bar. So that's why I put the 1 underneath. What was another example? I think that's about all that we need to keep track of. So let's actually look at one. Now, if you want to go back to the previous slide, what do we do with 2 exponents when we multiply the x's together? Well, if you recall, we just add them. Now, these ones are easy enough to add since the denominators are already the same. You just add the tops, 3 and 5, to get 8. Now, this 8 over 2, though, reduces to a 4. Decided back and forth whether I should make you go through the fraction operations by hand or if I'll let you use a calculator. I will let you use a calculator to compute. So if you wanted to type that in, you would add. Just beware, your calculator gives you mixed numbers. You would have to convert them to improper. So we'll look at an example of one of those. Okay, now this next example, first thing you want to do, power over root, get rid of the radical. Rewrite it as the power is 5, so that goes on top. The root is a 3, so that goes on the bottom. Again, we're going to add these powers together. However, let's see. Be careful. Your calculator would give you, what would it give you? 9, 4, 20. It would give you, let me write this down so I don't forget. It would give you 2 and 5/12 is what your calculator would give you if you just typed it in by hand. Okay, so this is a problem. You need an improper fraction like I wrote up here. Now, how did I get 29/12? Well, here's the rule. You take the denominator, 12, and you multiply it by the whole number, 2. Then you add whatever in the numerator, a 5, and you keep the original denominator. So 12 times 2 is 24 plus 5. So you can see how I got 29/12. Okay, so make sure if your calculator, if you're going to use it and you have an improper, make sure you convert it, if you have a whole number, convert it to an improper through this process I just did at the bottom of the screen. Okay, now here, I kind of alluded to it on that one slide where we went through all of our properties from before. When we're dividing, we actually subtract, our exponents. So I'm going to actually take 4/5 and subtract 2/5. And that would give me 4 minus 2, x to the 2/5. When you do that subtraction, that was easy because the denominators were the same. Okay. Let me warn you though, if you would have had 2/5 on top and 4/5 on the bottom, when you would subtract, your calculator, if you're going to use your calculator, it would have given you a negative number. Now, if you're going to use your calculator, you got to be careful because it automatically, whatever your calculator gives you, is automatically talking about a variable that's on the top of a fraction. So if your calculator gives you a negative number, you need to flip it to the bottom. And here's how you can kind of keep it straight and know where it's supposed to be. 2/5 and 4/5, which is larger? Obviously 4/5 is bigger, so whatever is left over should stay on the bottom, okay? So just be careful of those things, be watching. Now I like this problem. I want to do the same thing. I want to, as a couple examples ago, I want to get rid of this radical. So I'm going to keep, oh good grief. I'm going to keep x to the 5/3 on top. I want to get rid of the radical on the bottom. So power over root, obviously 3 is on top, but what number is on the bottom? A lot of times students give me a 1, but if you look at that radical, it's a square root house. Let me say it again, a square root house. So it's understood to be a 2 when there's no index there. So be careful about that. And just like on our previous one, we're going to subtract these powers now. So we're going to take 5/3 minus 3/2. And if you use your calculator, it should give you a 1/6. Or if you do it by hand, whichever is fine. Okay. Now, if you remember when our previous slide, when you have parentheses, we distribute that power in and we multiply the exponents. So that's what we're going to do here. Multiply those two fractions. Now, these ones are a little easier to do in your head because you just go straight across the top and the bottom. So this would be 6/21, which would reduce to, divide them both by a 3, to 2/7. Okay? So you could use your calculator. That one was just as quick to do by hand. Now this one, I want to get rid of the radical that's inside. So remember power over root. So 6/5 fifths, power over root, power is 6, so that goes on top. And then it's going to be just like the last one. I'm trying to distribute that power in, so I'm going to multiply those fractions. 6 fifths times a 1/3, which would give me, I'm just going to do it in my head because that's quicker for me. Across the top, 6 times 1, 6. Across the bottom, 5 times 3, 15. And that reduces to, both are divisible by 3. 2 fifths. Alrighty. Whoops. The next one, again, we're trying to get rid of parentheses, so we have to distribute, but we've had this conversation in class quite a few times. The number 6 and the letter X, they're different things, so they both get this power when you distribute it. So we want to cube 6, and then just like in our previous examples, since we're kind of distributing that power in, we're going to take 2 fifths and multiply it by a 3. So 6 cubed, if you use the power button on your calculator, you would get 216. And then 2 fifths times a 3, that would should give you 6 fifths. All right, that was a bad box, sorry. Keep buzzing through, get as many as I can in our time limit here. Now this one, it's kind of confusing. It might be easier to work inside out. Inside this radical, we see the power. This is where I'm headed, converting to power over root. So inside this big cube root, I see that x has a power of 7, but what is its root? Remember, when there's not an index there, it's a 2. So inside of this guy, we could get rid of that inside root house by writing it as a fraction. Power over root would turn it into 7/2. Now, I want to get rid of this outside radical now, but I don't see a power. I see the root, but there's no power this time. Well, there's always understood to be a power of 1, whether you just can see it out there, or if you want to put this guy in parentheses, there's always understood to be a power of 1. So whenever you need a power, it's a 1. That's understood. So now I have x to the 7/2 that's inside, but this is being raised, power over root, power of 1, a root of 3. So you should have 2 fraction exponents because you had 2 radicals in the original. Okay, so we're going to multiply those powers. Let's see, that would be 7/6, it looks like. Okay, now I like this example. If I would give you this problem, x over 4, x over 2, you would probably tell me, 2x is reduced and you have 2 on top. Okay, so 4 minus 2 leaves me with 2, and because 4 was bigger, those leftover 2 are on the top. Did those x's go away? No. Did they cancel? No. This answer would still be the same if I changed this problem and made it 3x in parentheses. Those powers, I would still do the same process and just keep what was ever in the parentheses. So this guy, it's the same thing. You're going to keep the 2x minus 1 and then just subtract 4/3 minus 2/3. And hopefully you know that that's going to be 2/3. Okay, so maybe I should write out what I did. I took 2x minus 1 and I just subtracted the powers, 4/3 minus 2/3. And that was just a side note. Okay, I'm not going to have time for this one, so I'm going to have to do a second part. So just type in the same title of this video, but we'll do a part 2. Keep learning, guys, and have fun.